When you clean the IR spectroscopy, apply some methanol and then use a Kim wipe to clean it up. Make sure you don't have any residue left on the iris.
Before you place the sample, you need to check the noise line called background.
Go to the home page, click Start, then click Next. You should see the line going up and down. This is called background noise. If you don't see it, clean the IR until you get this line. After checking the background noise, leave the noise constantly on the screen. When you have your liquid sample, use a pipette and place a few drops of your sample quickly before it evaporates. Notice that the spectrum on the screen changes as you place the sample. You don't need to screw down the pin. When you have a solid sample, use a spatula and place just a few pieces of the sample to cover the iris. Then screw down the pin until you hear the click. Again, notice that the spectrum on the screen changes when you screw down the pin. When you generate your IR sample from this base, click Next, click Data Handling, and click Go to ResPro. When you print off the spectrum, click the spectrum on the screen. Go to File, click Print, and make sure the correct printer is connected. If you go to Print and cannot select the Print option, make sure you click on the spectrum. Then click OK to print it off. When you exit the spectrum, do not save the file. After you've printed your IR, make sure to come back and clean up the IR plate. If you used a solid, make sure you don't leave any chunks on the base. This can mess up someone else's data. Make sure you throw your Kim wipe in the trash. After cleaning the IR, leave the IR with the background noise showing on the screen so the next person knows that the IR was cleaned. Here we have an IR spectra of one of these 4 compounds. We still don't know which compound it is. Let's analyze it. The first compound has a carboxylic acid and sp3 hybridized carbons. The carboxylic acid makes a distinct peak between 2500 and 3600 weight numbers. You can see an example of this peak in example 3 of your lab handout.
The peak doesn't resemble the size and shape of a carboxylic acid peak.
sp3 carbon bonded to hydrogen shows between 2,850 and 3,000 weight numbers, which we can see here. Also, when we have a carboxylic acid, we are supposed to see a peak at 1,700, which is distinctive carbon double bonded to oxygen, which we don't see here. We can rule out compound number 1. Compound number 2 has sp2 hybridized carbons, where you see the double bond, and an alcohol. An alcohol shows as a wide rounded band between 3,200 and 3,600, which is exactly what we see here. However, sp2 hybridized carbons bonded to hydrogen show between 3,000 and 3,100 weight numbers. This is not present in this IR spectrum, so we can rule out compound number 2. Compound number 3 has a ketone and sp2 hybridized carbons. As we mentioned before, carbon double bonded to oxygen shows as a huge band at 1,700, which is not present in this spectrum, so we can rule out compound number 3. Compound number 4 has an alcohol and sp3 hybridized carbon. Like we mentioned before, the alcohol peak will show between 3,200 and 3,600, which is present in this IR. We also have the sp3 carbon bonded to hydrogen. Because methanol has everything we expected according to the IR, and because there are no other significant peaks over 1,500 weight numbers, we know that this IR spectrum corresponds to methanol. Remember to use your goggles when analyzing your spectrum, even if you're not using any chemicals. It's for your safety.